Okay, next topic is unit vectors. And unit vectors are vectors that are 1 unit long. Now they don't, the ones we're most interested in are unit vectors in the direction of the axes, but that doesn't have to be the case. If you take Calc 3, you'll find that out. So this is the x-axis, and this is the y-axis. And let's say we've got a scale here where that's 1, 2, 3, -1, -2, -3. So if I draw a vector from the origin, 1 unit long in the x direction, so we'll call that, this is a special name, it's called I hat. The hat shows that it's a vector. So we can say that I hat is a vector in the positive x direction with magnitude 1 unit. So let's say I wanted to have a vector, let's say vector A is a vector in the positive x direction with magnitude 3 units. What we could say is that vector A is equal to 3, the scalar, times the unit vector in the x direction. Because vector A would be, it looks something like this, it would be starting the origin, would be 3 units long. So vector A is just vector I times 3 to scale it up. Okay, so we do the same thing in the y direction. We can say this is, let's get the units here, 1, 2, 3, -1, -2, -3. So I'm going to use red in this case. So red, this little red vector here, we call the j hat vector. So the j hat vector is a specific vector. So j hat is a vector in the positive y direction with magnitude 1 unit. So I could do the same thing if I had a vector B, which is 4 units long. It would be 4 times j hat. So what we can do is we can take any vector in any direction. So let's start with a vector that gives you magnitude and direction. So it's going to, vector starts at the origin, goes this way, and let's say, we'll call that vector A. So it's vector A by showing it the capital letter A with the vector sign. Okay. And we're going to call this angle theta. We're going to say it's 25 degrees. So from a component standpoint, we can say the x component of vector A is going to be the magnitude of vector A times the cosine of 25 degrees. And let's say the magnitude of vector A is 3 units. So A sub x is going to be equal to 3 units times the cosine of 25 degrees, which is 3 times cosine of 25 degrees is 2.72. And we can do the same thing for the y direction. It'll be magnitude of a times the sine of 25 degrees. I'm not going to write it out. But if you want to write it out, it's 3 times the sine of 25 degrees, and I get 1.27. So that's how you do it from a component standpoint. The way we can represent this in terms of unit vectors is as follows. We can say vector A is equal to 2.72 times the unit vector in the I direction plus 1.27 times j hat units, whatever the units are. So it's just another way of representing. It's a shorter way, more compact way of representing a vector by taking the x component of the vector, multiplying by this to show that this is the x component by using the unit vector in the I direction, and the same way here for the j direction. Turns out there's also, you can represent a vector this way as well, but we don't. You might see this when you do Calc 3 or vector calculus. You'll show it in this form. We use a different, we don't use parentheses or brackets. We use these kind of like greater than, less than sign, but it's not really, that's not what it is. And so this is another way of representing, this is your x component, this is your y component. And if you add the x and y components together, you get the resultant vector. So when you want to add vectors, if you have two vectors that are written in this form, so let's say we have vector A is 3i hat plus 4j hat, and vector B is negative 1i hat plus 7j hat. What is, when we say vector C is the vector addition of vector A and vector B, what we do, so what we're going to do is 3i hat plus 4j hat, that's vector A, and we're going to add to that negative 1i hat plus 7j hat. And this addition, you add the components, you add the i's together and you add the j's together. It's kind of like complex numbers. If you think about that, that's sort of the same thing. You know, we look at complex numbers, we can show that graphically as the x-axis is the real number and the y-axis is the imaginary number, and then you get the complex number. So it's kind of the same concept, but it's not imaginary or real, it's x and y. So negative 3i minus 1i is 2i, and 4j plus 7j, is 11j. And so the resultant vector has components 2i plus 11j. And that's your resultant vector. So it's just a short way of representing vectors using unit vectors. So you got a couple of problems dealing with that kind of notation. It's pretty simple. If you have a three-dimensional vector, you'd have a k hat, and then you would still add the components together. But in this case, it's just 2 dimensions, x and y, not z. Okay, so we're going to stop there relative to unit vectors.